Okay, next is dividing fractions by a fraction. Problem 1 in your notes is 5/6. Oh, touchy. 5/6 divided by a third. Now the modeling of this is going to look a little bit different than dividing by a whole number or a whole number divided by a fraction. So you'll notice we have 3 parts. The top one, we call this the whole. Okay? For these series, we're only going to be dividing a fraction by a fraction. But when we name fractions, you have to remember that that fraction is part of a whole. That's why we need to keep this whole on the top, so you know that that name means out of a whole. So we are taking 5/6. Now you'll notice I have 1, 2, 3, 4, 5, 6 parts. Since we're only dividing 5/6, I'm going to take this part out. And I want you to consider the fact that this part is not being used. It's no longer part of this whole equation. Now we're dividing it into thirds, and you'll notice that that's exactly what we did. We divided it into 1, 2, 3 parts. So the question is, how many thirds are in 5/6? Well, you know that we have of the 5/6, okay, let's mark that right here. If we mark that straight down, you'll notice that, okay, we're not using this. We want to know how many thirds there are. Well, we have 1 whole third. We have another third. There's 2 thirds. And then we have half of a third. So really we have 2 and 1 out of 2 thirds. So we call that a half. Now, that might sound kind of confusing because you're looking at thirds and your fraction is half. Keep in mind that this fraction means 1 out of 2 parts. There are 2 parts needed to complete the third, and we don't have all of it. We only have 1 out of 2. Now, if you think you got it wrong, well, then go back and let's do the algorithm of it, which many of the students are saying is ridiculously easy. You flip the second and multiply. 5 times 3 is 15, and 6 times 1 is 6. Okay, and I know that 15 divided by 6 is 2 times 6 is 12. If you subtract, that leaves 3 out of 6. And you know that 2 and 3 out of 6 is the same as 2.5. Now, when you do the algorithm and you do the model, you can feel all warm and fuzzy when they match. All right, so here's the second problem. Now, the second problem in CMP 4.3 is 2 thirds divided by 1/9. Now, again, we're dividing a fraction by another fraction. When you are working with fractions, remember that this is a name of a part. That means 2 out of 3, which means we have a whole. Now, the reason we put this on here, remember, is to remember that these names of these parts are in reference to a whole. So let's go to it here. We have 2 thirds. Okay, we're representing that first one. Now, 2 thirds, so we're not using this one. I'm going to cross it out. We're not using this part. Okay, and 9. So the bottom bar, you'll notice that I divided it into 9ths. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, these are that part that we've cut out. So how many 9ths are there in the 2 thirds? Well, let's count. There's 1, 2, 3, 4, 5, 6. And it divides evenly, which I really like, but it's not always going to be that way. So we count 1, 2, 3, 4, 5, 6. So the answer is we find 6 parts. There are, how many 9ths are in 2 thirds? 6. And of course, do the algorithm to check it out. 2 thirds divided by 1/9. Okay, again, find the reciprocal. 9 over 1 and multiply. Okay, 2 times 9 is 18. 3 times 1 is 3. 18 divided by 3 is 6. And what a warm fuzzy to see the algorithm match the model. All right, so it's listed as problem 6 in your homework, but This is actually the third problem in your homework or classwork here. It's written as 1/18 divided by 1/9. And you'll notice in your work, we already did the modeling for you. We want it to start a little easy. And remember the top part, we always want to keep the whole. So you remember that these fractions have a name. And that name is in reference to the whole, not just a part. So a whole, and then we have 1/18 divided by 1/9. So 1/18, we're only using this part. So what I'm going to do is cross off all of these. We're not using them. We're only looking at this part. And we're going to divide it by 1/9. This one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. The question is, okay, remember how to say it, how many ninths are in 1/18? Well, if you notice, 1/18 is smaller than 1/9, so you're not going to have a whole ninth. We only have part of it. We have 1 out of 2 parts, or 1/2. We need 2 parts to equal a ninth. So we don't even have a whole ninth. We only have half of 1. And again, let's check your algorithm. Okay, so 1/18 divided by 1/9, or another way to say it, how many ninths are in 1/18? Well, you know in your head, you can predict that it's not even going to be a whole ninth, because 1/9 is larger than an 18th. So let's find the reciprocal. 9/1. Multiply across. 1 times 9 is 9, and 18 times 1 is 18. 9/18 is 1/2. 9 divided by 9, 18 divided by 9. And our algorithm matches the